Welcome to C.6.1. Today we're going to describe the meaning of the term liquid crystals. Most commonly people think about liquid crystal displays like what's on our TVs, our phones, our laptops, and we definitely will get to that. So let's start with just what this actually means. So liquid crystals are fluids that have physical properties, so electrical properties, optical properties, and elasticity properties that are actually dependent on the molecular orientation relative to some fixed axis in the material. Okay, well that sounds kind of like a mouthful, so what does that actually mean? Well, if we were to think about a solid has everything arranged in a similar organized pattern. And so in this case, when we're talking about liquid crystals, they're always rod-shaped molecules, something that's sort of long and thin. And so if the liquid crystals are in the solid state, they're aligned like this in a rigid, organized structure. They can also be in the liquid phase, where if their temperature is high enough, they become disorganized in such a way and free to move. So for example, they would flow past each other, through each other, and they'd be in other directions. But a liquid crystal is something that's sort of in between these two states, and it's only exhibited by these sort of rod-shaped molecules that have certain properties we'll look at later. But what you can see here is actually the direction that they're all sort of facing on average is still similarly along one axis. So these are all sort of vertically aligned. However, if we were to animate this, these are still free to flow up and down within that structure. So we have some organization, but not as rigid as a solid, but not completely disorganized like a liquid. And so this is what we call a liquid crystal, because there's some structure but it can flow. So some examples of liquid crystals are graphite, cellulose, which is found in our plant cell walls, the solution that actually forms silk when a spider is making a web, DNA, soap, and Kevlar. And Kevlar has been a material we've looked at before as a polymer. So there's some connections you can draw there. Liquid crystal materials may not always be in the liquid crystal phase. So this phase will only exist in a certain temperature or concentration, and we'll look at that in another